Quite correctly, a lot of public attention as to the cause of City Hall's problems has been its location on a swampy site. But over the years, much of the excess moisture from this once swampy site has been removed as neighbouring buildings helped to pump the excess water away. In reality, the main source of water problems in recent times has been up on the roof. This photograph, taken 1 year after City Hall opened, gives you an idea of how the roof was originally. But over the years, several structures have been added, including, amongst other things, to accommodate an inner-city kindergarten that started with just 10 children in the 1940s and grew to over 100 in the late 1990s. Sadly, the roof was leaking like a sieve, and the building structures themselves were frankly dangerous. It all had to go, and what was left behind was a scary sight indeed.
The floor surface has been exposed, and it shows a fairly pitiful example of what has been used in the past to protect the floors below from water ingress. Technology that was used 60, 70 years ago, never been tested in Queensland conditions. The membranes came from Northern Europe and they were used to a cold climate. That type of membrane obviously doesn't have any movement and there's cracks appear. You can see the effect of the harsh Queensland conditions on the roof. It's quite evident that in the past, whenever they did any repairs, they just put a band-aid on it. Obviously at the weakest point, then the water found its way to the next weakest point. But this will be complete stripping back to the concrete and applying a liquid membrane that will be tested to make sure that there is no chance of any leak, and then we cover that again with protection.
The impact that decades of roof leaks has had on the building is almost beyond comprehension. It even took the engineers by surprise. And as we're about to see, without urgent restoration, City Hall was heading on a path to becoming uninhabitable.
There was a problem with the roof. The waterproof membrane on the roof failed. Also, the concrete is quite porous in places, so the water's been able to flow through the concrete in the roof. It's been able to come into contact with the reinforcement, and as the reinforcement's corroded, it's expanded and it's spoiled the surface of the concrete.
If you have a look up here, we are on the top floor of City Hall. That area above us is the roof slab, and this is a beam that holds up that roof slab. You can see how the reinforcing is completely devoid of any concrete, and all the cement has actually washed clean away to the extent where if you just touch this material, you can see how weak it is, and it's just all loose, and there you go. That's how weak it really is. It's turned into just sand. This beam has effectively become a gutter. It actually, water literally pours straight through it, to the extent where that beam now has structurally failed.
Some of the reinforcement is very badly corroded. Some of it's only surface corrosion, so we can clean that up and repair the concrete. But the most serious areas, we'll have to put new concrete and new reinforcement in. We've taken a huge number of core samples from the concrete throughout the building. We've taken in excess of 200 which have been taken away for strength testing. So they've all been tested for strength. We've also tested chemical composition of the concrete. We've also used ground penetrating radar to actually see what reinforcement is within each of the members. This is a core sample we've taken from the existing concrete frame of City Hall. This isn't necessarily a bad sample. You can't tell whether this is high strength or low strength just looking at it, but that's why we've tested these.
The fact that it's a very rough surface where the drilling is processed, it's plucked out the surface, would indicate that it's possibly a low strength specimen. With its fracture going down, this one is also liable for rejection. But we will test this one and look at it in respect of all the others. The concrete can only stand a certain amount of force, and this is related to its strength. So this machine will compress it until such time as it fails, and we'll record the amount of load that it's applied, and therefore we can determine its strength. these older concretes, and particularly the weak concrete. The test is over very shortly.
This is the lowest strength concrete I've ever seen in any building. I've worked on heritage buildings in the UK and I've never come across anything quite like this. It falls well below what modern concrete is capable of achieving. Even the code of practice for concrete design doesn't recognise concrete as low as we're finding in City Hall. It was made in line with best practice for the time and with the materials and equipment they had available. They didn't have the modern pumps or mixers that we have today. So it was really down to the people on site batching, how diligently they mixed the concrete, how well they were able to mix the concrete, what materials they had available.
Now that they've tested the concrete and investigated and mapped out the structure of the building, it's time to make way for the work to repair and strengthen the structure. But the question is, how long will these repairs last?
I can see no reason why City Hall shouldn't last as long as people want it to. Once we've fixed the roof, once we've fixed the basement, we eliminate the two main problems, the two main sources of water into the building, so we should arrest the deterioration in the concrete.
Now that engineers know exactly what they're dealing with, it's time to start planning for the important work to strengthen the building. But before they can do that, they need to get access to the original structure. And this requires bringing in heavy machinery and stripping away layers of surfaces added over the years.
Yeah, didn't think I was going to make it through that last doorway. Oh, very nervous, yeah. When you started hearing stuff creaking and that, yeah, I was very nervous. Yeah, but Jono was saying it's all right, so it's cool. If the boss says it's cool, it's cool.
Coming up next, see the enormous transformation underway throughout the building as the original architecture finally starts to see the light of day.